Okay, here are solutions for quiz 7 for Math 251. For the first two, we are asked to find derivatives. For this one, you might have known because of what section it is, we're dealing with logs, and we learned logarithmic differentiation. Turns out we don't have any rules that'll take this derivative just the way it's written. Kind of looks like power rule or something, but that won't work here. What we have to do is rewrite this as an equation which we can then algebraically manipulate till we get to the point where we can take the derivative of both sides. And the trick that we'll do is we're going to take the natural log of both sides. The reason I knew to do that is because really what's causing the issue is this sine of x up in the exponent here. And the trick for getting things out of the exponent is if you first take the log of those things, you can then move exponents. We have this log rule that says anytime you're taking the log of something raised up to a power, you can take that power and bring it down in front of the log. So this is equivalent to this. But this is much better than this because this we can take the derivative of both sides, this we couldn't. So now what we've done, we haven't done any calculus yet, but I've rewritten things in a form for which we take the derivative of both sides. So that's what I'm going to do now. The derivative of natural log of y. Careful, this is actually chain rule. The outside function is natural log of x. The inside function is the letter y. Y is itself a function. So what I do is take the derivative of the outside part. It's 1 over whatever your argument is. Your argument in this case is y. Then you're not done. You have to multiply that by the derivative of your argument. In this case, the derivative of y, which is y prime. What about the right-hand side? That looks like product rule to me. F, the first thing is sine of x. G, the second thing is the natural log of sine of x. So the derivative of sine of x is cosine of x. And then we can leave the second thing alone. And the product rule says to that you want to add the derivative of the second thing. So the derivative of natural log of sine of x. This is chain rule inside the product rule. The derivative of natural log of x would be 1 over x, so the derivative of natural log of sine of x is 1 over sine of x, times the derivative of sine of x, which as I already said was cosine of x. And then be careful, we also have a sine of x over here. This, maybe I should label these a little bit. Using the notation that we use in our class, this is f prime, this is g, this entire thing is g prime, and this is f. So what I'm saying is we got 1 over y, y prime is equal to, I want to figure out what y prime is equal to, so maybe I'll multiply both sides of the equation by y and get that y prime equals y times all this stuff. I'm not just going to copy it verbatim, although I'm going to do something very close to that. So far I'm just copying everything, but note that I have 1 over sine of x times sine of x. This and this cancel out, and I just get plus cosine of x. This is your derivative, but there's no y's defined in the problem, right? That's just something we made up. It's weird to define the derivative of y in terms of y. What we instead want to do is y is just equal to this mess. So instead of writing y right here, I could say, instead of y times all this stuff, let's say sine of x raised up to the sine of x power times all this stuff. Cosine of x, natural log of sine of x, plus cosine of x. Something like that. Okay, part B. For this problem, we won't have to use logarithmic differentiation. We won't have to set up an equation, do all that. We can just take the derivative. Everything on the right-hand side is something we know the derivative of. It's not easy, but it's stuff we know. So we're being asked to take the derivative of something. The notation we've been using in our classes, we'll call that something f times something else. Call that g and apply the product rule. So f is the natural log of log base 3 of x, and g is log base 2 of the natural log of x. If I could just figure out f prime and g prime, I would be done. That's the good news. Bad news is those aren't too easy to figure out. We got to use the chain rule. So in this case, the outside function is natural log of x. The inside function is log base 3 of x. So taking the derivative of the natural log part tells me I should get 1 over log base 3 of x. But then I'm not done. I have to multiply that by the derivative of the inside function, which is log base 3 of x. The derivative of log base 3 of x is 1 divided by x natural log of 3. Over here in g prime, my outside function is log base 2 of x. My inside function is natural log of x. So if I take the derivative of the outside function, the derivative of log base 2 of x is 1 over x natural log of 2. But my argument is not x. It's not log base 2 of x. It's log base 2 of natural log of x. So my derivative is 1 over natural log of x times natural log of 2 times the derivative of natural log of x, which is 1 over x. Here's all the pieces. Put those pieces together in red, maybe? Sure. And we get that f prime of x is equal to f prime 1 over x log base 3 of x natural log of 3. I wrote these in a different order. I wrote the x out front just because I think it's prettier that way. Times g log base 2 of the natural log of x plus g prime 1 over, I'm again going to change the order here. I like the x out in front. X natural log of x times natural log of 2. You don't have to change the order. I just think it's prettier this way. Times f natural log of log base 3 of x. It's a perfectly good answer the way it's written. Or if you want, this times this is log base 2 of natural log of x divided by x log base 3 of x times the natural log of 3. Sure. And then to that I want to add this thing, the natural log of log base 3 of x divided by x natural log of x times natural log of 2. Something like that. Either of these are good. I don't care which one you use. Either will work as your answer. All right, related rates. The trick for related rates is there's two different things that are changing. If you read this question, the volume is changing and the length of a side is also changing. So what I need to do is I need to start out with some sort of equation that relates together the length of a side of a cube and the volume of that cube. That formula is that volume equals maybe s for side cubed. So now that I have this equation relating together volume and the length of a side, I can take the derivative of both sides of the equation, treating both v and s as functions, maybe functions of time if you want to think about it that way. The derivative of v would be v prime. The derivative of s cubed is, careful here, we'll have to use the chain rule. Taking care of the cubed part, I get 3s squared, but then I'm not done. I have to multiply that by s prime. This is the relationship for which I'll have to plug in all the numbers. If you go through and read the question, it says the volume of a cube is increasing at a rate of 60 centimeters cubed per second. So the change in v is 60. I don't care about units. What it's asking is how fast the length of a side is increasing. In other words, s prime is what we want to know for our answer. And it's telling me that the length of a side right now is 2. I want to know how it's changing when it is 2. We'll plug in the values over here. V prime is 60. S is 2. So what I get is that 60 equals 12 s prime. 12 being 3 times 4. And so if you divide both sides of the equation by 12, you get s prime equals 5. Which is perfectly fine. I don't care about units. Maybe I'll say or 5, what am I talking about here? Centimeters per second. But I'm fine with this being your answer. All right, what about B? Turns out it's pretty similar to A there. Really what you need is the picture. So what's going on here is there's this house or wall or something here, and a ladder leaning up against the wall. The ladder is 5 feet. 5 feet. And what it wants to know is how fast is the base of the ladder moving horizontally. So what's going on is this ladder is kind of falling here. This is going down and this is going out. It's sort of sliding. And so what we want to know is how fast is this thing moving when this is moving at a given speed. I think the easiest way to do this is go ahead and put two variables in, x and y. Sure, why not? Two letters. You're allowed to have two letters when you're dealing with related rates. And then using this picture, come up with the relationship that ties together these three numbers, these three values. Well, might be easier to see if I really emphasize that this is a right triangle. We have this Pythagorean identity that says the sum of the squares of the lengths of two sides of a right triangle is always equal to the square of the hypotenuse. A squared plus b squared equals c squared. So in this case, x squared plus y squared equals 25. What I now have is a relationship between the two unknowns, x and y. So I can take the derivative of both sides of my equation. A couple things to be careful of here. X and y are both functions of time. So I have to treat them both that way. This is chain rule, this is chain rule. It's a little bit tricky. The derivative of 25 is just 0. Okay, so what do I know? X, which is what I'm calling the horizontal distance, y is the vertical distance. It says, how fast is the base of the ladder moving horizontally? Sounds like x prime is what they're asking me for. If the top of the ladder, which is 4 feet off the ground, sounds like they're telling me y is equal to 4, is falling vertically at a rate of 12 feet per second. Well, if you look at this, it might not look like we have enough information, right? I want to figure out x prime. I can solve this thing for x prime, sure. 2x, x prime equals negative 2y, y prime. So x prime equals negative 2y, y prime divided by 2x. Or if I really wanted to simplify, I could cancel out the 2's and call it negative y, y prime over x. I know y, I know y prime. I want to know x prime, but I still need to know what x is. Fortunately, I can figure out what x is. The way I figure out what x is when y is 4 right here, 5 squared should be equal to 4 squared plus x squared. I can solve this equation for x squared and get that x is equal to 3. Really plus or minus 3. But in this case, since we're talking about length, we can just call it positive 3. So what I can do is I can plug in those values. Negative, see, it looked like y was 4, y prime is 12, and x is 3. I think that's negative 16, which is the answer. Okay, so what does that mean? The negatives are a little bit weird. The reason it came out negative is because we thought about moving in directional. Like if you think about this as a vector, negative means it's moving this direction. We could have made y negative mean it's going down, and then the 16 would be the right sign. What I'm getting at is when you get this answer, I think negative 16 is totally fine. But I'm also going to put or 16 feet per second. Or 16. Any of these answers are perfectly fine. Negatives just come up when you're worried about which direction things are moving in, whether they're moving to the left or the right. And when you're worried about that direction, you have to be really careful on what you're defining to be positive and negative. Right? Since my ladder is falling at a rate of 12 feet per second, maybe this should have been negative 12. We'll still get the same values throughout here, but this would have been positive 16. So you have to worry about that when you're worried about the direction. But since I'm just worried about the speed, I don't have to worry about any of that. I just call this good. And that would be the end of this quiz.